Hello everyone, I've got an example here. So this would work for chapter 2.5, 2.6. I have a given, so I denote the axes by the red pen. And then I have force 1, which is a blue pen with a magnitude of 300 newtons, and a force 2 down here, 500 newtons, denoted with an orange pen. And I've given the the direction of force 2 given the actual angle. So you can see that the 45-degree angle would actually be negative. So your z is actually going negative. Your y is actually going so it would be 60 degrees from the x, and then 120 degrees to your z, and then 45 to your y. And then over here I'm giving you 60 degrees to force 1, and that is from the xy plane. And then I'm showing that this line of action right here is 45 degrees from the y-axis. So I have what we're finding the resultant position vector and the magnitude of the two forces given. So my approach, and how I'm going to approach this, is I'm going to say, first thing I'm going to do is break into position vectors for each force. And then 2, we're using vector addition. Alright, so then my solution. So when I'm looking at my solution here, the first thing I want to do is I want to find I want to call this f prime, and I'm going to draw it in pink right here. I'm going to call that f prime, f1 prime. We'll call it f1 prime. So I need to find the vector right here on this xy plane. And how I do that is I say well, first of all, we look at this and say 300 newtons. So F1 prime is 300 newtons times the cosine of 60 degrees. So you see this is 60 degrees here. So we're trying to find this vector. So this is the adjacent side. So I have 300 newtons times the cosine of 60 degrees, which would equal 150 newtons. Then I can come in and find my x, y, and z for that force, for the magnitude of force 1. So F1 is going to be equal to negative 150 newtons, using this here, and this is in the x direction. And since I'm denoting this as positive x going here, going back this way would be a negative. So that's why I'm denoting that this is a negative 150 times the sine of 45 degrees. Here you go, got 45, and you got sine of 45. And then I come in and say plus, and I'll say I, plus 150 newtons times the cosine of 45, and that's in my j direction. Then I'm going to say, okay, so my z is still going to be 300 newtons, because that's still, that's not in my xy plane, so it's 300 newtons, and that's going to be times the sine of 60. So now we're looking at this one right here, and that's going to be in my k direction. So using my calculator, I come up with negative 106 in the I direction, plus 106 in the j direction, plus 260 in my k direction. The key to this is to find this f prime. Once that f prime is found, it's a lot easier to solve for. Then if I look at f2, now I've given all the angles to that vector. So this one's a little bit more simple that I can just say the cosine of 60 times 500 newtons plus the cosine of 45 500 newtons minus 500 newtons times the sine of 30 degrees. And if you notice, if we would cut this 120 degree angle at the xy plane, below it would be 30 degrees, because 120 minus 90 would be 30, and it's going down, so it's going to be a negative in the negative z direction. And I will go back and write in my I, my j, and my k. So again, using my calculator, I get 250I plus 353.6 j minus 250 k. These are all newtons. Okay, so then my position vector for my resultant force would be this. So my position vector FR is going to be the x plus the x, my y, and my k's. So I can come in and say negative 106 plus 250 is 144I. That's going to be positive. Then here I'm going to say this is going to be plus 106 plus 353 is 459.6 J. And then I'm going to say 260 minus 250, we can say that's going to be 10 plus 10K. And all in newtons. So now this is what we call the position vector, the resultant force in its position vector form. These are the position vectors for F1 and F2. These are the position vectors. Good. So now we can say the magnitude of FR, and then that's where we're just talking about Pythagorean theorem. So we have 144 squared plus 459.6 squared plus 10 squared. So my FR, then I take the square root, then I take my FR, that's going to be 481.7 newtons. So now we have solved for the resultant, the magnitude of the resultant. So there's my magnitude, so there's an answer. And then I need to find my direction cosines. Let's scroll down just a little bit. So my direction cosines. So you could graph this, these numbers, and then you could write out to each angle where the position vector would be. And earlier in the lecture, we came up with that the cosine alpha is the Fx over the resultant force. The cosine beta, which is, so this is from my x, this is from my y, and this is from my z-axis. And this would be cosine gamma. And this is going to be Fy over Fr, the magnitude, and Fz over the magnitude of the resultant force. So plugging in my values, I got 144 for x. My resultant force was 481.7 newtons and newtons. And remember, you're going to be taking the arc cosine of each one of these, the arc cosine of each one of these. So this would be 459. Sorry, that looks like a 7. 459 over 481.7 newtons. And then this one would be 10 over 481.7 newtons. So after I do that, I get cosine, arc cosine of 0.298, the arc cosine of 0.954, and the arc cosine of 0.023. So that's this would be alpha is equal to, this would be beta is equal to, and this would be gamma is equal to. So then I get 72.6 degrees, 17.4 degrees, and 88.8 degrees. Note that you should keep your negatives on here because that will help you note whether what side of the axis is on, if it's on the positive or the negative side. So these would be your direction cosines. So again, a real quick recap. We were trying to find the resultant position vector in the magnitude. My approach was to break into its position vectors for each force. So there's my position vectors that I came up with. And then I did my vector addition, which should, now that you've had some practice on it, all we're doing is we're adding them, the x's, my y's, and my k's. Again, f prime is a major component. You have to find f prime in the x, y if you're just given a few of the angles. Now, force 2, we were given all the angles to that one vector, so we could solve for that pretty easily. I'll probably go over one more example. I like to break these up just so that they're not too long for you. If you have any questions, please post and we can discuss. Thanks.